Alright, we are going to do 3.1 homework. It's been a minute since we've had any homework, and I don't know about you guys, but I miss calculus. Alright, we're going to do the chain rule today. Chain rule is, I'll be honest, not always fun. It takes a lot of practice to get used to the chain rule. And it's really not hard. The only thing that's hard about the chain rule is remembering when you need to use it, because you're going to see some things, you're going to take the derivative and you're going to be like, alright, I'm good, but did you use the chain rule? That's the question. You should always be asking yourself, did I use the chain rule? Because odds are you probably need to use the chain rule for most derivatives that you're taking. So just takes a lot of practice to get used to it. Alright, so first question. We got y is equal to cosine of pi over 2 minus 3x. Okay, chain rule is all about going outside and in. So take the outside derivative and start working inside. So what I mean by there's cosine of x, that's a function. But then now we don't have, but now we can look on the inside. So remove all of this right here. And now I have to think about what's the derivative of the inside part. So there's two parts. Well, sometimes there's 3 or 4 parts. Outside part, inside part. It's always outside working in. So trying to find dy dx here. So derivative of y with respect to x is going to be equal to, well, I know that the derivative of cosine is negative sine. So negative sine of the inside part needs to stay the same. So pi over 2 minus 3x times by, now this is where I'm going to look inside. I'm going to ignore the outside. I'm going to look inside and think about what's the derivative of this inside part. Well, the derivative of pi over 2 is 0. The derivative of negative 3x is negative 3. So times by negative 3. And if you simplify this, you'll get 3 sine of pi over 2 minus 3x. And there you go. For 2. Now, multiple rules are going to have to happen here as well, because I not only have the inside part of this cosine function, there's also a product here, product between x and cosine, which means I have to use the product rule. The product rule is kind of the first thing that needs to go here, because the product happens before I take the derivative of cosine of pi minus 4x. So the product rule is what I'm going to start with first. So dy dx is going to be equal to, I'll take x, which is the first function, first part of the product, and I'll multiply by the derivative of this. Now the derivative of the second part is what's going to require the chain rule. So times by, I'll say negative sine of pi minus 4x times by the derivative of the inside. So now I'm going inside right here. What's the derivative of the inside part? Derivative of pi is 0 since it's constant. The derivative of negative 4x is negative 4. So kind of recapping here, this was the first part. This was the derivative of the second part with the chain rule. Plus, now I'll have to take the derivative of x, which is 1, times by the second. So times by cosine of pi minus 4x. Probably some cleanup here. You can clean up a little bit of this right here. That's going to be equal to 4x sine of pi minus 4x plus cosine of pi minus 4x. As far as simplifying, we all know that you don't have to simplify your derivatives. Okay, but also if I see here that that's not really much of a stretch to go from here to here, I'm probably going to make that simplification. If it's something that's a little bit more complicated, then I'll probably won't simplify. Alright, for 3. So dy dx. I don't see a product here except for the constant with the function and the constant with the function, but I don't have to use the product rule if it's a constant with a function. I can just treat this as the constant multiple rule. So the derivative of this part right here, I'm basically just going to take the derivative of this part and multiply it here, but there is a chain rule that's taking place right here, the derivative of the inside. So the derivative here is going to be 4 over 3 pi times by cosine of 3x. Okay, now I'm going to pause. I just took the derivative of this. Now I need to go inside. So the inside is 3x and the derivative of 3x is 3. So multiply by 3. Plus, actually it's going to be minus because when I take the derivative of cosine it's negative. So taking the derivative of this part right here, minus 4 over 5 pi. And like I said, the derivative of cosine is negative sine, which is why I put negative here. So sine of 5x. Now I got to stop. I got to go inside. The derivative of 5x is 5. So times by 5. Okay. I can clean up a little bit. I see that we've got the 3 right here, which would cancel with the 3 in the denominator here, the 5 with the 5 in the denominator there. So that's how you can clean up. But I think I'm going to move on. For 4. Alright, so we have the exponent property, the power property, not the property, the power rule. The power rule, which is going to take place, so we'll take the derivative as if we're using the power rule, but then I'll have to go inside the parentheses to take the derivative. So starting with the power rule, so dy dx is going to be equal to negative 2. Inside is going to stay the same. This is going to decrease by 1. So we just took the derivative of the outside part, which was drop the negative 2 down, decrease by 1. Okay, now I have to go inside here. Going inside, take the derivative of x plus the square root of x. So times by, or I'll just do another set of parentheses, 1 plus 1 over 2 root x. And there you go. So this was the derivative of the outside part. Then I went inside, took the derivative of the inside. There you go. There's no more inside I need to go. I can't go inside of x. I can't go inside of the square root of x. Their derivatives are just going to be 1. So I can't go inside any further. I guess you could, but the derivatives would just be 1. Okay. For 5, looks like this is very similar to what we just did here. We're going to use the power rule. So y prime is going to be equal to negative cosecant of x plus cotangent of x to the negative 2. Alright, so I took the derivative of the outside function. Now I'm going to go inside right here. Look at what we have here. Take the derivative of that. So multiply by the derivative of cosecant, which is negative cosecant of x times by cotangent of x, and then minus the derivative of cotangent of x, which is cosecant squared. Cosecant squared of x. Yeah, and this is definitely one that I would look at and be like, even if I could simplify it, I don't really want to. Ways that you could simplify it: put this in the denominator, maybe factor, maybe you can work something out there. Maybe some trig identities, but I don't think it'd be worth your time. For 6, before I take the derivative here, it might be easier to rewrite it. So sine squared of x can be rewritten as sine of x squared, and then minus cosine of x cubed. So this is just kind of easier for me to see the power rule when it's written like this rather than when it's written in this format. So I'm going to take the derivative, I'm going to drop the 2. So it's going to be 2 times by sine of x. Now I'm going to go inside the parentheses and take the derivative of sine, so times by cosine of x, minus 3 cosine of x squared, and I'm going to go inside and multiply by the derivative of cosine, which would be negative sine, so I'm just going to make that positive right there, and do sine of x right there. And that's all I'm going to do for that. Alright, I hope you guys are ready for this video, because there's a lot of derivatives here. But I know you guys are going to hate me for it, but then you guys are going to be grateful for it, okay? A lot of practice for the chain rule, because we need it. We need more practice. We need all the practice we can get on these ones. Alright, for y, when I first see y, the first thing I see is the product, and as I take the derivative, as I use the product rule, eventually I'll have to take the derivative of this, and this is where the chain rule is going to be needed. So let's first start with the product rule. So y prime is going to be, I'll take the first, which is x to the third, and I'll take the derivative of the second. This is where the chain rule is going to happen. So we're going to drop the 4. I'm going to put the 4 in front of the x cubed. So 4, and then we'll have 2x minus 5 to the third. Now I'll have to go inside of this part right here and take the derivative of the inside. The derivative of 2x minus 5 is going to be 2. So hope you guys don't mind. I'll go ahead and simplify as I go. So that's going to turn into 8, because I'm going to multiply this part by the derivative of the inside, which is 2. Okay, and then, so I think I'm done with that part. So I did the first times the derivative of the second, and I used the chain rule, and then plus the derivative of the first, which is 3x squared, times by 2x minus 5 to the fourth. And there you go. Okay, I have another product here. Again, I also see this sine to the third of x, so I'm going to write this as sine of x to the third times by tangent of 4x. So you can see that we need the product rule between those two terms, and I'll need the chain rule for both, because there's the sine of x, which is inside of the power, and then I need the chain rule here for inside of tangent. So the derivative of y with respect to x is going to be, so we'll take the first, so I'll write sine of x to the third times by the derivative of tangent of 4x. I'm going to use, no, I'm not. Yeah, I'm not. So let's do the derivative of tangent. The derivative of tangent is secant, so we'll do secant of 4x. No, it's secant squared, right? Yeah, it's secant squared. So secant squared of 4x times by, now we'll do the chain rule, times by 4. So I'll just put the 4 right here. Okay, so I did the first times the derivative of the second, and then I didn't forget the chain rule, and then plus the derivative of the first part. So we're going to bring the 3 down. It's going to be sine of x squared. Now I'll have to go inside and take the derivative of sine, which is cosine of x, and then times by the times by the second, so times by tangent of 4x. There you go. For 9, I don't know why there's no y equals, probably a typo by me. But first of all, I'm going to rewrite this as 4. Do I want to rewrite that? You know what? I'm not going to rewrite that. Because I know what the derivative of the square root of x is, right? So when I take the derivative of this, I'll just say y prime is going to be equal to, the 4 is going to remain, and then it's going to be 4 over 2 square root of secant of x plus tangent of x. So this is just The 4, because I mean it's just a constant multiple, so that's just going to be that's just going to stick around. The derivative of this is just like taking the derivative of the square root of x. It's going to be 1 over 2 square root of x, except instead of x we have this inside function, and then this is where the chain rule is going to come into play. So we're going to multiply by the derivative of the inside. The derivative of secant of x is secant of x times by tangent of x, plus the derivative of tangent of x, which is secant squared. Okay, and that should be good. I bet there's a lot of simplifying you can do here, but that seems like a lot to simplify. For 10, I would probably rewrite this one. I would rewrite this as 3 2x plus 1 to the negative 1/2, because we know that the square root is power 1/2, but bring it to the numerator. This is just so I can use the power rule. And so I'll use the power rule. I'll bring the 1/2 in front. So this y prime is going to be equal to negative 3/2, 2x plus 1 to the negative 3/2, whenever I subtract 1 from that. Then I'm going to have to multiply by the derivative of the inside, so multiply by 2. And you can kind of see that that would cancel if you were to simplify. For 11, ooh, yikes, we got a quotient rule here. So you can see the quotient that's taking place, and I'll have to take the derivative of the denominator, and that's where the chain rule is going to happen. But let's start with the quotient rule. So y prime is going to be equal to, we're going to need low d high, and the derivative of the top is 1, minus high. Now we're going to take the derivative of the square root of 1 over x squared, which is going to be 1 over 2 square root of 1 plus x squared. And then I'm going to multiply by the derivative of the inside. The derivative of the inside will just be 0 and 2x. And I'm just going to write that in the numerator, 2x. And then you can see that can kind of quickly simplify right there, if you were to simplify. So kind of retracing my steps, what I did low d high minus high d low, and this required the chain rule. And then we're going to square the bottom, so that's actually just going to be 1 plus x squared whenever I do that. So if I square a square root, that's going to go away. Alright, for 12, so y prime, I see 2 chain rules that are going to take place. So I see this as an inside. I also see this as an inside to cosine. So we're going to work outside first, so we're going to drop the 2. 1 plus cosine of 2x. And now this is going to be to the first power if we subtract 1. Now I'm going to have to multiply by the derivative of the inside part. The derivative of 1 is 0. The derivative of cosine is negative sine. So negative sine of 2x. But now I'm going to have to go inside of cosine, so go into the 2x and take the derivative of that. So times by 2. If you were to simplify, I can see some multiples, so like 2, negative, and 2. So you can put negative 4 out front, then the rest of that. For 13, y prime is going to be equal to, again, I think I see a double chain rule. If I rewrite this as sine of 3x minus 2 squared. So I'm going to bring that 2 out in front. Then it's going to be sine of 3x minus 2. So there's one chain rule whenever I bring the 2 down. Oh wait, I haven't even done the chain rule yet. So there's going to be the first chain rule when I take the derivative of sine of 3x. So that's going to be times by cosine of 3x minus 2. Then I'm going to have to go inside of that and take the derivative of 3x minus 2, which would be 3. For 14, we have y is equal to e to the 2x. Well, I know that the derivative of e to the 2x is going to be e to the 2x, but now I have to multiply by the derivative of the inside, which is going to be 2. For 15, so y prime is going to be equal to e to the negative x times by negative 1, since the derivative of negative x is negative 1. For 16, y prime is going to be equal to e to the negative x over 4 times by negative 1/4. For 17, okay, when I take the derivative of this right here, I'll take the derivative of these terms separately because it's just subtraction. Now I need to use the product rule. Whoa. Oh man, did you guys see that? I was like this close to thinking that this was a function of x, but it's just a constant. Oh my gosh, wait, why is this even in here? I don't need the chain rule at all here. What the heck? When I take the derivative of this, it's just going to be e squared minus e to the x. E squared is constant and times by x. So this is a linear function right here. It doesn't look linear, does it? This is a linear function with a slope of e squared. So the derivative of that is just going to be e squared. And the derivative of e to the x is e to the x. 18. Now, this one looks like, wow. Product rule and product rule. I don't see a chain rule at all. What in the world? Okay. Why not? There's no chain rule. So y prime, so when I take the derivative of this part right here, we're going to have the first times the derivative of the second plus the derivative of the first times by the second minus, I'm going to use parentheses here. This is really important. Because when I take the derivative of this product right here, that negative would eventually need to be distributed. So this is important right here. So we'll do the first times the derivative of the second plus the derivative of the first, which would just be 1 times by the second. Okay, so that's why we need parentheses here, because now I have two terms. And I'm just going to leave it right there. Don't know why that's in here. I probably knew last year when I made this assignment, but now I can't remember. Alright, this one will require the chain rule though. So y prime will be equal to e to the square root of x. Now I have to go inside here and take the derivative of square root of x, so times by 1 over 2 root x. Okay. What in the world? 8 to the x is just going to be 8 to the x times by the natural log of 8, if you remember your derivative rules. But the inside is just x, so no chain rule is needed. So, okay. 21, that's looking more like it. So y prime is going to be equal to 3 to the cosecant of x times by the natural log of 3. So this is the derivative of the outside part, so the derivative of 3 to the x, but now the inside also needs a derivative taken, so multiplied by the derivative of cosecant, which is negative cosecant of x times by cotangent of x. Alright, looks like we have natural log of x squared, so there's no parentheses here. They typically... yeah, that's the inside part, so that's where the chain rule is going to happen. So we'll say y prime is equal to 1 over x squared, since the derivative of the natural log is 1 over x, but the inside part is x squared. And then we'll multiply by the derivative of the inside, so we're going to multiply by 2x, And so that's going to be equal to 2 over x when we simplify. Okay. Oh, wow, look at that one. Natural log of the natural log of x. Okay, so y prime is going to be equal to 1 over the natural log of x, since the derivative of the outside part would be 1 over natural log of x. Now we're going to have to multiply by the derivative of the natural log of x, which is 1 over x. So I guess you can write that as 1 over x, natural log of x. Okay. For 24, I would rewrite this as the natural log of 10x to the negative 1. Okay, so when I use the derivative, I'm going to do 1 over 10x to the negative 1 times by the derivative of the inside. So the derivative of the inside will drop the negative, so it's going to be negative 10x to the negative 2. Okay, and I just that one's an easy one to simplify, and it kind of just like bugs me that it got all those negative exponents. So also the 10s would cancel, so it would be negative. I can put this up in the numerator, so x in the numerator over, then I could put this in the denominator over x squared, so that would be equal to negative 1 over x. Cool. All right, for 25, so we have a product here, and then we have sum and difference there. So say y prime is equal to, let's use the product rule here. So the first times by the derivative of the second plus the derivative of the first times by the second minus 1. So that's going to be equal to 1 plus the natural log of x minus 1. So that's going to be equal to the natural log of x. No chain rule there. So, okay. And for 26, so y prime is going to be equal to, this is a log, and the derivative of log, if you guys can't remember, so the derivative of log base a of x is equal to 1 over x times by the natural log of a. So this is going to be equal to 1 over square root of x times by the natural log of 5. Now I will have to take the derivative of the square root of x, which is 1 over 2 root x. So this looks like it's going to simplify to 1 over 2x times by the natural log of 5. 2x because we got the 2, and then square root of x times square root of x is x. But yeah, there you go. All right, so hopefully that was a lot of practice to the point of where you guys hate it, but also where you guys feel more comfortable using it, okay? And don't worry, there's more in this next part.